In this question, it is given that the integral this is equal to, where c is a constant of integration, you have to find the correct choice. The normal way of doing this question is tough and lengthy both, but I will tell you a way which is very short as compared to the normal way. My way of doing this question is, it is clear that the integrand, this whole, is an even function, and you must be knowing that integral of odd function is always even function. But in the case of integral of even is odd, this is valid if in the integral for x equal 0 the answer is 0. For example, the integral of cos x is sin x. It is even function, it is odd function. But sin x plus 1 is also the integral of this, but it is neither even nor odd. That is, the concept is the integral of even is odd provided in the answer for x equal 0 answer is 0. In this case, for x equal 0 answer is non-zero, therefore this is neither even nor odd. But in this case it is odd. For example, 1 upon under root dx is minus, we know this thing, and integral is, this is also true, but constant of integration is also there. Here also plus c and here also plus c. But we always adjust the constant of integration in such a way that for x equal 0 the whole becomes 0. In this case, we will have to take the value of c as pi by 2. Then only the value of this will become 0. In this case, we will have to take the value of c as 0. Then only this will become 0. And note that the integrand is an even function, hence the integral must be odd function. Clearly this is odd function if I take c equal to 0. This is also odd function if I take c equal to 0. This is neither even nor odd for any value of c, because I just now told that we try to adjust the constant in such a way that the value of this whole becomes 0. It is clear that for x equal to 0 it is 1, it is 0 plus c. That is, if c equal to minus 1, the whole will become 0 at x equal to 0. But even if I take c equal to minus 1, even after that also it is neither even nor odd. Similarly, this is neither even nor odd if c equal to minus 1. Hence, it is clear that b and c are sure to be. And now for c equal to 0, it will become odd. For c equal to 0, this will also become odd. But now we have to choose out of these two which one is correct. The only difference between them is minus and plus. If the integral of this is this, then the derivative of this must be this. But to differentiate it and bring it in this form is also not an easy task. What I do, let me differentiate it first, then I will tell you. After derivative, immediately I can say this is correct or this is correct. I will not have to differentiate it and simplify it, because differentiating it and simplifying it is very tough job. Let me differentiate it first. I want to check a. Let us differentiate first. I will get the answer secant square x minus x sin x plus cos x whole square, and here I will be getting x sin x plus cos x into the derivative of x sec x. Don't worry, it's not going to be lengthy. Just see my steps. Derivative of x sec x is x sec x tan x plus sec x minus x sec x into, here derivative of this will be x cos x plus sin x minus this into this. This is here. If the integral of this is this, then the derivative of this must be the interior part, that is this must be equal to the interior part, that is x upon x sin x plus cos x whole square. If they are equal, without simplifying, I can easily check they are equal or not. If they are equal, then they must be equal for every value of x, because I know that one of these is correct. Had I taken this, I would have got plus here. Let us put x equal 0 on both sides. The right hand side is 0 for x equal 0. Left hand side will be, here I will be getting 1 minus this whole will become 1, because this is 0, this is 0. Cos 0 into sec 0, that will be 1 into 1, 1 minus this into this will be also 0 for x equal 0. That is, left hand side is 1 minus 1 and right hand side is 0. Hence for x equal 0, both are equal. Had I taken plus here, then I would have got 2 on left hand side, right hand side is 0. Hence they cannot be equal. That is, after simplifying this, I will never get this thing. Therefore I can say A is correct.